Hello and welcome to the 6th video for the Meyer MAPP 3D assignment number 4. This assignment is for the Speaker Systems Design and Optimization course that runs at New England School of Communications at Husson University. In the previous video, the previous part of this assignment, we time aligned the mains and subs to be not time aligned, we level aligned the mains and subs to be equal level at this point in the center of the venue. So they're equal level in there. But now we want to time align them or phase align them so they're equal in phase at that point and see what the kind of combined coverage is if you have equal level, equal time. So returning back to measurement view. And earlier, when listening to the mains only, I clicked the auto button, which aligned the impulse of the mains, the left and right impulse, to be at the 0 point in time. So it's actually applied 35.47 milliseconds of delay. That is the travel time it takes for these mains, for both of them to hit that microphone. So we've already done that. If you haven't done that already, you're going to want to do that. And you're going to want to do that with it doesn't matter too much, but it's in this situation, we really want to just listen to the main, so we want to mute the subs. So if you select the Gracie Galileo, express settings, make sure the subs are muted, and do a prediction. And if you haven't done so already, hit the auto button and time align that impulse right to 0. I want to make sure I get to the next step here. Oh yeah, we want to store a trace of this. So I know in class you guys have used SMART. This is sort of like a virtual SMART system. It's called SIM down here. SIM is actually a precursor of SMART. And we're going to store this live frequency response, this live data, we're going to store it to a memory location down here. So store live trace. And this particular trace is going to be called mains at center mic, because we are listening to the ORC center mic and we are listening to the mains. So we've got this stored down here. If you want the trace to be visible, you hit the little eye icon, and then it overlays it on top of the live trace, and you see pink because red and blue together kind of make pink. With the mains captured, let's mute them, all 4 input channels are for the mains, and let's open up the subs, and we'll do a prediction. Now you can see the live subtrace overlapped, and earlier we were looking at just the subzone, so let's do that again, 15 hertz to 400 hertz, just look at the lower frequencies. We'll do the same thing for the phase trace here, lower frequencies only, up to 400 hertz, and you can clearly see that they are not in phase, although they are equal in level. And as we've learned in class, let's kind of zoom in and look at the phase trace. Which system needs delay? Is it the subs or the mains? Intuitively, you'd think the subs would need delay because they are closer to the microphone than the mains. So we would probably need to delay the subs and wait for them to arrive, wait for the mains to arrive. So that's kind of the intuitive guess. It's hard to tell with the phase trace. We've learned in this class that steeper angles mean that that system producing that phase trace, if it's steeper in angle, it is later in time, it is seeing more phase wraps, and so you want to delay the other system to meet the later system. And it's pretty hard to tell here which one of these is steeper. In fact, they're pretty close to the same angle. It's very difficult to tell here. So this is inconclusive about whether I want to delay the mains to reach the subs or the subs to reach the mains. If I zoom out and I look at the impulse, it gives a different story. The impulse, you can see that most of the subs are later in time to the mains. So this is kind of telling me that we actually might need to delay the mains to reach the subs. Interesting. If you zoom in even closer, we put our window to 14 milliseconds. Now you can kind of see what's going on here. The subs do indeed reach the microphone first. But due to group delay, phase shift, lower frequencies are delayed later in the subs. And at some point in this impulse, we encounter 80 hertz, 80 hertz being our crossover frequency. And you can't tell from this impulse where 80 hertz fits. If you are aligning two high-frequency loudspeakers or two similar loudspeakers, you can just align their impulses on top of each other, and that works very well with front fills and those balcony fills and those sorts of things. But since we're comparing a main and a sub here, we have no idea where 80 hertz is. So we can't use, excuse me, I hit the microphone. We can't use the impulse response. Instead, we have to use the phase trace. And I can see here clearly, I'm thinking the subs are later, so we need to delay the mains. So let's move on with our, have we captured the subs? No, we haven't captured the subs yet. So we must have just done a prediction with the subs. Let's store the subs, store live trace. It's going to be called subs at center mic. And save. We're going to make that visible, and we're actually going to hide the stored mains trace because we're going to need to delay the mains to reach the subs. Makes sense? I've kind of talked through all of this just in the last couple minutes. Before we start delaying, there's one kind of catch here. We have our mains assigned across 4 drive lines, right? If you go select the mains and you look at them, in the last assignment, we had put the top 2 boxes on a drive line, then 3 boxes, then another 3 boxes, and then the bottom 2 boxes are on the 4th drive line. And this is well and good, and this is good, and this is what you should have done, and both of our main systems are both set up this way. The catch is when we go to adjust delay time, we have to adjust the delay time for each output between every prediction. And this is frustrating. Even when we go over to inventory and we select the Galileo, we go back to express settings, we're still going to have to change this 4 times. So I actually suggest you go back to the speaker and put them all on one drive line for this step of the process. And later, once you have your delay time, put them back on their separate outputs. So this is actually pretty simple to do. Let's take speaker, the left mains. We'll go to the object settings, and we just have to very carefully put everybody on top box 1 and 2. And of course, you'll want to reset this later on. And truth is, for this particular assignment, it doesn't matter. That was the last assignment that we cared more about output assignment. This assignment, it's just, put them all on 1 and 2. Now, this has set up the left array to be all on one drive line. The right array is not. The right array is still the old way with multiple drive lines. The easiest thing to do now is actually delete that, and we'll just select the left array, mirror along the y-axis, it puts it back in the same place, select it, and in object settings, assign it back to, oops, I clicked the wrong button there, move it back to the mains right layer. So now we have all of our drive lines on one processor channel, or all of our loudspeakers and the mains are on one processor channel. So it will make it a lot easier to adjust delay. So go back to inventory, and let's select the Gracie Galileo, go to express settings. And again, I want to see the subs, and let's mute the subs, and we only need to unmute one main. And let's do a prediction. And there we go. And we're back to where we were a few minutes ago. And now we're going to add delay to the mains to try to get them in time. So how much delay? I mean, they're pretty close in angle, so I don't think you're going to need very much. You can use your little calculation here and kind of see, well, how out of phase are they? This is at 60. That one's at 80. It's like they're about 120 degrees out of phase-ish is kind of what it looks like. So can we change that with delay? Well, start adding delay and see what happens. So let's add a millisecond. Did that help? Let's add 2 milliseconds. It almost looks like it's moving farther away from being in phase. It's not quite helping. 3 milliseconds. Will it eventually get there? That's the question. And maybe it's creeping closer, so I'll go to 5 milliseconds. It's getting closer. I'm just going to skip up to 7 milliseconds here to save the process. And we're close to in phase now. 80 hertz is our target. And we're pretty close here, maybe another millisecond. But if you understand this process, as we've learned it elsewhere in class, you can see now that the angle of the phase trace is quite a bit steeper for the mains. The mains are in blue. So it is late in time. We've actually gone the other way now. I wonder if you could see this if we zoom out. The mains are pretty, I think we've missed 80 hertz. I think 80 hertz is some. We're late in time. So what do we do? Sorry, wrong trace. We need to look at the phase trace. I'm going to get rid of that delay and going to point out something that should be obvious to you, which is at 80 hertz, they're pretty much parallel but almost over 100 degrees out of phase. What about a polarity reverse? Maybe a polarity reverse is what we really need, reverse polarity. And they're a lot more similar at this point. So let's add a little bit of delay. Now we've polarity reversed it. Ooh, I can just hit return. It automatically predicts. That's great. That's way faster. And I'm going to put 3 milliseconds. Hopefully I don't go too far. And so it's sort of debatable now. You can't make it perfect. You can't make it perfect because the subs, these 750 LFCs, are not of the same vintage as the Meyer Melodies. They are of a different era, and they are not perfect in phase response. But we have gotten pretty close here, and maybe it's like 2.5 milliseconds of delay kind of gets 80 hertz in phase, right? So there's our magic delay time, 2.5 milliseconds. And let me go back to the instructions, make sure I haven't skipped anything here. I've kind of gone through the process of prediction and then alignment. So once you have achieved this, and of course it may be slightly different for you than 2.5 milliseconds because your mains are slightly angled, articulated differently. I don't know. You may have a different result. But once you get equal level and equal time, which we have at this point, equal level and equal phase, I need you to take a screenshot of the entire measurement window showing equal level, showing the impulse moved in time, showing, not gobbledygook, like kind of clear phase lines here. So you have to make sure that delay has been set properly. And take a screenshot, in this case Command-Shift-5, of the entire window. Because you're going to turn this in. This is how I'm going to grade and give you comments and feedback regarding your alignment. Name that screenshot 03 center aligned dash measurement dash your name. All right? And again, I don't want to see gobbledygook. It needs to be readable, and your screenshot should look something like this, which is, of course, what I created here. Save your file, and in a moment, we will analyze your results, okay? Save your file. See you in a second. Goodbye.